let's start with some questions. You guys have any questions from worksheet 1 here? Nick?
You do one.
Which one?
Like the first one.
I was just messing with you. I knew what you meant. All right. So let me grab one of these guys because this is just all about reading the unit circle. All right. So first thing I'm going to want to do is I'm going to go to my interval and I'm going to identify which quadrants are covered by the interval from pi to 2 pi. So if I go to my unit circle, I find pi, which is right here. And because these are positive angles, pi to 2 pi, we're going to be rotating counterclockwise. So I'm going to keep rotating until I get to 2 pi, which would be right there. So we're covering quadrants 3 and 4. Now remember that tangent is y over x on the unit circle. And so if y over x is -1, that would tell me that like y equals -x. So x and y should be the same number, but different signs. So I'm going to go look in quadrant 3 and 4 for a place where x and y are the same, but different signs. I notice here, oh, but they're the same sign. So I go here, that's what I want. So my answer should be 7 pi over 4. And 7 over 4 is the decimal 1.75. Which is definitely in between 1 and 2. So I'm convinced that I have my answer. And I'm all done.
Wait, can you go back to the unit circle?
Sure. Yep. That's what like x or y equals -x is saying. So the same number but a different sign. Emily. Sure. Was that on page 2, I think? Okay. I just asked because I didn't copy the whole thing. I just got to go back and copy the rest of it. All right, let's see. 12. Okay. So first thing, let's identify 13 pi over 2 to 15 pi over 2, where that is. So I'm going to erase my marks over here. So we're starting at 0. So that's 1 over 2, 2 over 2, 3 over 2, 4 over 2, 5 over 2, 6 over 2, 7 over 2, 8 over 2, 9 over 2, 10 over 2, 11 over 2, 12 over 2, 13 over 2, to 14 over 2, to 15 over 2. So we're in quadrants 2 and 3. So far, so good. And again, to get that, I just kind of counted, right? Now, if I look at here, I have cosecant. Well, remember cosecant is the same thing as the reciprocal of sine. And so if I have this equation, if I flip both sides, it's the same thing as saying that. But I still don't recognize that as a y-coordinate on my unit circle, right? But what if I rationalize the denominator? Aha! That looks like something I'm going to recognize. So I'm going to go back over here, and I'm looking for where the y-coordinate is -√2 over 2. in quadrants 2 or 3. So that's my spot right there at 5 pi over 4. Right? So this is like 1.25. That's like 6.5. And that's like 7.5, right? So if I add 2 pi to that, it would get me like 3.25. Still not big enough. So add 2 pi again. That'll get me to 5.25. Still not big enough. I'll add 2 pi again, which will give me to 7.25. Yes, that's in between. So I'm just going to make a common denominator with these and now add the fractions, right? So that common denominator would be 4. So each one of these is going to turn into 8 pi over 4. So 8 plus 8 plus 8 plus 5 is 29 pi over 4s. Does that feel okay? And notice how like I defaulted to decimals here a little bit to just make it easier for me to like, why make a bunch of different common denominators and like add these fractions? Like I can tell it's not going to be big enough. Let me just dump it into decimal or decimal town till I figure out how many times I have to add the pi, and then it just makes, or the 2 pi, and then it just makes it easier to do the cleanup at the end there. Does that feel okay? Cool. All right. How we doing? Feeling okay here? More or less? So we're going to continue on today talking about stuff in 4.1. And we're going to look at a new kind of problem today that's similar to the kind of problem we worked at last time, but a little bit different. Because here we're going to be using our calculator exclusively and not the unit circle. So this one is going to require a little bit of picture drawing for our point. Okay, so setup wise, looks very, very similar to the previous assignment, right? The difference here is that that's not a unit circle value. That's our Q that we are going to have to use our calculator to do this. Unless I recognize that thing at the end as a unit circle value, like 1/2, root 3 over 2, root 2 over 2, 0, 1, or if it's tangent, maybe I have like root 3 over 3 or root 3 by itself or 2 or something but this is clearly like a kooky decimal. That's not a unit circle value. So what I'm going to do is I'm going to start by identifying what quadrant that angle theta, the terminal side of that angle theta has to lie in. Okay? So to do that, I'm going to first figure out from my interval what 2 quadrants my answer needs to be in. What 2 quadrants are covered by pi over 2 to 3 pi over 2? Yeah, so if I remember, I know that every 90 degrees is a pi over 2. So between 90 and 270, that's quadrants 2 and 3. Okay. So the other piece that I'm going to use is that sine is negative, or sine theta is negative in this particular problem because it equals negative 0.72. So I need to figure out what two quadrants sine is able to be negative in. Well, I remember that sine is equal to the y-coordinate, and the y-coordinate is negative in quadrants 3 and 4, right? Now you can think about it that way. Or if you remember this acronym, all silly turtles crawl, what that acronym tells me is the trig function that is positive in that quadrant. So A stands for all of them, sine, cosine, tangent, all positive in quadrant 1. In quadrant 2, S says sine is positive in quadrant 2. So if sine is the only one that's positive in quadrant 2, what are cosine and tangent then have to be? Negative, right? The T in quadrant 3 stands for tangent. Tangent is positive in quadrant 3, but sine and cosine would be negative. And the C in quadrant 4 stands for cosine. That's positive in quadrant 4, but sine and tangent are negative. So I like that as a way to remember. So if I look here, so my interval is covering quadrants 2 and 3. My sine being negative covers quadrants 3 and 4. So where is my answer have to be in? Has to be in quadrant 3, right? Because that's the only quadrant that's common or that will satisfy both of those requirements. So there I'm going to draw my angle theta. Yes? So this piece, this information I colored blue, right? But the thing that overlapped the yellow and the blue is the green. That's where my answer is because it has to satisfy both of those two conditions. Is that okay? All right. Everybody so far so good? I'm now going to introduce another measurement. I'm going to introduce the measurement for the angle alpha. Alpha is going to be the angle between the x-axis and the terminal side of theta. I'm going to underline x-axis because this is the part that I see students make mistakes on. Is some of us will try to put that alpha in between the y-axis and the terminal side. No, 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 no. Has to be the x-axis. Or what we're about to do will not work all the time. Okay? So you see where I've drawn in the alpha between the terminal side and the x-axis, right? So the way that we're going to calculate alpha in this problem is going to be sine inverse of the absolute value, I should say, let's do this, the absolute value of sine inverse negative 0.72. Where did the negative 0.72 come from? Y sine inverse. Everybody see where those two things came from? All right. Now what I'm going to do is I want to write an equation based on the picture that I've drawn that relates theta, the end of the x-axis that the terminal side is closest to, and alpha. So what can we say there? So if I followed theta from here to here, that's pi, right? Everybody agree with that? And then if I go from pi to the terminal side, that was alpha. So in this picture, I can say theta equals pi plus alpha. Everybody buy what we just did there? Hold on one second, guys. I made a boo-boo here. This absolute value is supposed to be, needs to be there. Sorry. So now I am ready to go to my calculator. So I'm going to do pi plus sine inverse. And then to find the absolute value, I can press math. And I go over to the number tab. And I can pick the ABS command. Or if you wanted to skip all that, what else could we do? You just type in positive 0.72, right? You just do the absolute value in your head. So I get the value 3.95. Everybody's okay there? Let's check this, because this is checkable. There's two things we have to do to check this. One, if I take sine of 3.95, I better get negative 0.72, right? So let's try that. Sine of answer. That part worked. Everybody feel good there? The other thing I want to check is to make sure 3.95 is bigger than pi over 2, but smaller than 3 pi over 2. So definitely bigger than pi over 2. Definitely smaller than pi over 2. So what can we say? That's our answer, right? Let's do another, yeah? Yeah. Correct. Which was 4.7 or something.
Oh.
Right, I just typed it in. Yeah, 4.71. So it's definitely in between those two, right? Okay. So let's say we have cosine theta equals negative 0.57, and our theta needs to be between 4 pi and 5 pi. So let's start by drawing our picture. Yes, sir. Oh, yeah, thank you. I don't know, I said it. Yeah, absolutely, thank you very much. So 4 pi to 5 pi. So let's see here. So 0, pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, 7 pi over 2, 4 pi, there's our start, 9 pi over 2, and then 5 pi. So we're talking about then quadrants 1 and 2. Everybody feel okay with what I did there? Notice as I counted around, I crossed the value off when I got to something coterminal to it, right? Like the first time around, I crossed off the 0 and wrote the 2 pi. The next time around, I crossed off the 2 pi and wrote the 4 pi. Everybody's good? It's important that you're doing that when you're drawing your picture. You must be able to construct the picture I'm drawing here in order to be able to write your equation for theta correctly at the end. So the picture is the hard part here. All right. So we notice this problem, cosine theta is negative. So the quadrants where cosine theta is positive are A and C, quadrants 1 and 4. So that means we're negative in quadrants 2 and 3, right? So where is the terminal side of our angle going to lie? In quadrant 2. That's correct. The only quadrant in common between both criteria. Now, just so we're clear, when I'm drawing my terminal side here, does it really matter where it's at in quadrant 2? No, just needs to be in quadrant 2, right? So I just draw that terminal side somewhere in there. I usually stick it in the middle. It's 2, 4. So there's my angle theta. Remember, I had to go around 2 times before I ran into the terminal side, right? Remember drawing angles like this before in chapter 2? Right? Now I'm going to label my alpha. The alpha always goes between the x-axis and the terminal side of my angle. So that's going to be my alpha. So my equation that I'm going to write needs to relate theta, alpha, and the side of the x-axis that's closest to the terminal side of theta, which in this case is 5 pi. So here I notice that theta is smaller than 5 pi, right? Because it doesn't cross the 5 pi. Everybody agree with that? So maybe the equation I write this time, it says 5 pi is equal to alpha plus theta. Because if I stop at theta and I go alpha more, I'd be hitting the x-axis. Everybody agree with that? So to get theta by itself, I'm just going to subtract alpha from both sides. And again, in this case, alpha is going to equal the cosine inverse of the absolute value of 0.57. So that's what I'm going to type into my calculator, is 5 pi minus cosine inverse of the absolute value of 0.57. So 5 pi minus. Now, instead of typing in the absolute value in my calculator like I did last time, I'm just going to do that and just do the absolute value in my head and skip the buttons. You guys are all cool with what I did there? Now, I'm always going to write the absolute value on my paper, but when it comes to my calculator, I'm just going to save myself the buttons. So I get about 14.74. Let's check that, though. So if I do cosine of that angle, I do get negative 0.57. Wonderful. And then if I take 4 pi, well, 1474 is definitely bigger than that. And if I look at 5 pi, 15.7 is definitely bigger than the 14.7. So we're good. How are you guys feeling so far? It's okay? If you're able to draw your picture correctly, you should have or should be able to consistently get correct answers fairly easily, right? If the picture is hard, it's going to be hard, right? Because we need the picture to get our equation for theta. You know what I'm saying? All right, let's do another, because there's one other little hiccup here that we need to be worried about. So let's say we have negative 3 pi is less than or equal to theta is less than or equal to negative 2 pi. And we want to find tan theta equals negative 2.62. So first things first, let's figure out where this is going to lie at. So 0, and then because it's negative angles, I'm rotating clockwise. So this is negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. Okay, that's my start. Negative 5 pi over 2 to negative 3 pi. So we're looking in quadrants 3 and 4. So far, so good. Then we're looking at where tan theta is negative. Well, I can see that from All Silly Turtles Crawl, tangent is positive at A and T. So we're positive in quadrants 1 and 3, which means we're negative in quadrants 2 and 4. Oops, wanted to use blue. So quadrant 2, and then quadrant 4. So where is our answer got to be at? Quadrant 4. So let's go ahead and draw our angle. So again, we're going we're going clockwise because it's a negative angle. So negative 2 pi, and there, yes, sir. So we know that tangent is negative, right? Because it's a negative number. So the A says all sine, cosine, and tangent are positive in that quadrant. The T tells me tangent's positive in that quadrant. So the places where tangent isn't positive would be quadrants 2 and 4. Is that okay?
Yeah.
So I'm just kind of doing it like like a set complement thing, right? Like a negation. It's an inverse from geometry is what we called that statement, right? When we negated it. Okay. So let's draw in our alpha now. Everybody's okay here? So far, so good? So we now need to find an equation that relates theta, negative 2 pi, and alpha. Everybody's okay with that? So if we look here, it seems like theta is past negative 2 pi, right? Everybody agree with that? So it looks like I should just do negative 2 pi plus theta, or I'm sorry, plus alpha equals theta, right? Unfortunately, this is wrong. And this is wrong because theta is a negative angle. So if theta is actually past negative 2 pi, it means theta is smaller, it's more negative than negative 2 pi. So instead of adding alpha, we really need to be subtracting. That'll always be the case when you're dealing with a negative value for theta, which we can tell right away that we have because of the interval that we're given, right? So if I go to my calculator and we do negative 2 pi and we subtract tan inverse of 2.62. Remember, I'm just doing the absolute value in my head, right? So I can skip having to press the buttons. If you want to press the buttons, though, that's okay. So I get about negative 749. So let's check that still, though, right? I love having checks. So I do tangent of that angle should give me the negative 262. Beautiful. Negative 3 pi should be smaller. It is because it's a more negative number. And then negative 2 pi should be bigger. Which it is because that's less negative, right? Everybody agree? So that's our answer. What do you think on this so far? Is this okay? So again, it's about drawing the picture, right? If you can get the picture, that's what we need to get the equation. This is kind of like the hardest level problem, in my opinion, when you start getting the negative angle measures. It makes it a little tricky because everything, like all your intuition is opposite of what it should be. Because if I look at the picture, it's like, oh, look, theta goes past negative pi over 2, so I just add alpha to that. It's like, you just need to remember to subtract there. That's the most common mistake. The good news is, though, if you added alpha there, what's going to happen when you try to check? Is it going to work? No, it wouldn't have worked. Here, let's show you. So say we added alpha instead of subtracting. There's our answer. If I do tangent of that, look, I got the wrong value. Oh no! Right? And that would be my cue that like, okay, I did something wrong. Let me go back and look, right? And oftentimes if you're off by like just the sign, it's probably that you've added instead of subtracted or something like that. Or you forgot to do the absolute value and make it negative or something like that. That's usually the fix. You ready to try some of these on your own? This is as far as I want to go today. This skill is, I think, plenty to do for one day, right? This is not simple, although I don't think that difficult, but it requires like a good amount of attention and dealing, like getting comfortable with skills that maybe we haven't used in a while, and really being able to read a picture. So I think this is a good place to stop and let you guys have some practice. You guys cool with that plan? Okay. So your assignment for this should be worksheet 2. That'll be due this Sunday along with worksheet 1. Everybody's good with that plan? So that'll be the problem set for Sunday, will be worksheets 1 and 2. We'll do some more on on Wednesday. And then we'll also I'll have a assignment for you on the asynchronous day, but both of those assignments for Wednesday and the asynchronous day wouldn't be due till the following Sunday. Everybody cool with the plan, man?
So the homework we get Wednesday and Friday is not due till
the following Sunday. Yeah. Like like a week from Sunday. Yeah. Sound like a plan? Everybody okay? Plugging along, going all right? Does this feel like we're getting our feet under us a little bit? I know at the start of the semester it probably felt really hard. Hopefully things are starting to feel a little bit easier as we're going. And we're getting caught up and up to speed on like some of the notation, the vocabulary, the way I do things. Right? Maybe? Okay. That's what I hope anyways. Okay. I'm going to stop talking now. You guys can spend the rest of our time here together working on worksheet 2. If you have questions on things, please feel free to come up and bother me. Show me what you got. We'll talk through where we're at or what you need to do next or whatever. And if you're efficient, I see no reason why you couldn't come close to finishing this thing, right? What do we got left here?
like 30.
Yeah, you got like, if you're doing like 3 to 4 minutes a problem, should be able to finish the sheet kind of in that time frame, right? That's not absurd. And you can certainly finish a good deal of it, right? Leave yourself like 15 minutes left or something. If you can't finish it today or right now, probably finish it in CT after this. You know.